Here's an example of a question where we're going to use the squeeze theorem to find the limit. We want to find the limit as x approaches infinity of sine x over x. Now, from your knowledge of limits, we know that that's the limit as x approaches infinity of sine x multiplied by the limit as x approaches infinity of 1 on x. So using multiplication rule, this as x approaches infinity, we know that sine x will go somewhere between -1 and +1. So as x gets close to infinity, we don't know which one of these two values it is approaching. This one's easy enough. As x approaches infinity, 1 on x, so this will approach 0. 1 on a large number is 0, but this one is going from -1 to +1. So we can't just use substitution to work it out, so we're going to have to use the squeeze theorem. Now we know that sine x lies between -1 and +1. The very nature of the sine graph, we know from work previously done with periodic functions that it oscillates between +1 and -1 sine x. So we know that, and if we divide, x is getting close to infinity, so x can't be equal to 0, so we divide right through by x, and we get -1 on x sine x on x, which is our function that we're trying to find the limit for, +1 on x. Now these are my two other functions. In other words, this function is going to lie between -1 on x and +1 on x. So this function will lie in between those two. But we know that the limit as x approaches infinity of -1 on x is equal to 0, and the limit as x approaches infinity of the other function, 1 on x, is also equal to 0. So by the squeeze theorem, because this function sine x on x lies between -1 on x and +1 on x, then by the squeeze theorem, the limit as x approaches infinity of sine x on x, because these two here are equal, then, and this one lies in between, so it must also equal 0.